Welcome to our channel Kalmari Junior. We are doing chapter number 4, Chemical Thermodynamics. Today we will be studying Hess law of constant heat summation, spontaneous process and entropy. So let us begin. Hess law of constant heat summation. The law states that overall the enthalpy change for a reaction is equal to sum of enthalpy changes of individual steps in the reaction. The enthalpy change for a chemical reaction is the same regardless of the path followed by the reaction. This law is a direct consequence of the fact that enthalpy is state function. That is, the enthalpy change of a reaction depends only on the initial and final states of system and not on the path followed by the reaction. This can be illustrated in a diagram. When a reactant changes, A changes from A to D, then the enthalpy changes related to the reaction are delta H. A can be converted to D in 3 steps by A converting to B, B converting to C and C converting to D. Then, according to this law, the value of delta H can be calculated as sum of the enthalpies of H1, H2 and H3. Explanation for Hess law. To determine the overall equation of reaction, the reactants and products in individual steps undergo mathematical operations as shown below. Consider the synthesis of ammonia molecule. Required equation is N2 plus thrice H2 giving twice NH3. Then, to calculate the enthalpy of reaction, we use the Hess law as follows. First, twice H2 plus N2 gives N2H4. The enthalpy for this reaction is plus 95.4 kilojoules. Second, N2H4 plus H2 giving twice NH3. The enthalpy for this reaction is minus 187.6 kilojoules. The required equation is obtained by adding equation 1 and 2. Then, the enthalpy change can be obtained by delta HR is equal to delta H1 naught plus delta H2 naught. That is 95.4 plus minus 187.6, which is equal to minus 92.2 kilojoules. Application of Hess law. The law is useful to calculate enthalpy changes of those reactions which cannot be determined experimentally. Also to calculate the enthalpy of extremely slow or fast reactions. Further, to calculate the heat of reaction which may not take place directly as shown earlier. Let us now study spontaneous process. The key points are: it occurs on its own and does not require any external agency to occur. It is irreversible process. Like you can see, water falling from the waterfalls will fall on its own and it cannot be reversed back to the top. The spontaneous process can be rapid or slow. Example, coffee placed on a table will cool on its own by loss of heat energy, but this will be a slow spontaneous process. The spontaneous process being natural, it will occur till equilibrium is reached, like ice cubes melting to turn into water. This process will continue till entire ice has turned into water at the same temperature. Energy and spontaneity are related. Let us see the relation. The spontaneous reaction takes place in a direction in which the energy of system is lowered. For example, neutralization of HCl by NaOH is exothermic reaction. HCl plus NaOH aqueous gives NaCl aqueous plus H2O liquid. The enthalpy for this reaction is minus 57 kilojoules. Cooling of hot coffee in a mug will release heat to the surroundings. This is also an exothermic reaction. Both these processes are spontaneous. However, ice will melt spontaneously above 0 degrees Celsius by absorbing heat. Common salt will dissolve in water by absorbing heat from the surroundings. The reaction is NaCl plus H2O gives HCl plus NaOH aqueous. The enthalpy of the reaction is plus 3.9 kilojoules. Both the above processes are endothermic but spontaneous. Thus, we see that exothermicity is not sufficient criteria for spontaneity. So, a new criteria for spontaneity is introduced, that is entropy. Now, what is entropy? Let us consider following examples. When ice melts, highly crystalline arrangement of water molecules collapse. When liquid water will vaporize, gaseous water molecules move freely and randomly in available space. Observe the pictures. Ice cubes turning into water, water when heated turning into vapor. We see that randomness or disorderliness of the system is increased. Ice cubes had a specific shape and volume. Turning into water destroyed its shape, and turning into vapor state set it free in the environment. Thus, the measurement of this disorder or randomness is called as entropy. The definition of entropy is measurement of degree of randomness or disorderliness is called as entropy. It is denoted by capital letter S, while the change in entropy is given by delta S. The pictorial representation of entropy is as follows. Higher the randomness or disorderliness, higher will be the entropy. As the molecules come closer and closer to form a perfect shape, the randomness lowers and the entropy becomes less. Greater the disorder of a system, larger is its entropy. Example, when iodine dissolves in water, I2 molecules move randomly. Here, disorder increases and hence the entropy will increase. As you can see in the picture, on dropping the violet color iodine crystals in water, they are set free, turning the color of water to purple. Hence, delta S change in entropy is positive value. Thank you for watching the video. I thank my teammates for helping me to make the video. In the next lecture, we shall be studying entropy. We shall be studying second law of thermodynamics and Gibbs free energy. Until then, stay tuned. Bye.